In organic chemistry, we want to understand structure. And in general chemistry, often we have small molecules that we understand by Lewis structures. So for example, hopefully everyone can understand here is a Lewis structure of water, and that's a small molecule by anybody's definition. These are maybe, or this is maybe a small molecule by my definition. Maybe it's big by yours. It's called diclofenac. If you were to open up a prescription for diclofenac and look at the insert, this would be the picture that you would see. And so we all hopefully understand Lewis structure. So here's a Lewis structure for water, and as our molecules get bigger, we want to be able to draw things more simply and understand them. And so one of the things that you probably all have done before is you've substituted bonded pairs with lines. So every one of these line segments is an electron pair, a bonding electron pair. And so if we had methane, then we'd have a picture like this, and we'd all understand that as the equivalent of a Lewis structure. But you can see even with other small molecules, it gets really tedious to have to draw absolutely everything. And so what we want is a simplification of these drawings. And so here's a molecule that is in the same category as this kind of a drawing. So what are we going to do? Well, we're going to understand valence. We don't want to have to draw Lewis structures. We want to understand valence. I want to be walking around with a picture of this in my mind all of the time when I'm thinking of water. I don't want to have to stop and figure out a Lewis structure. I want to have it in my mind. And so if I have such a structure in my mind, then there are some things that I can do to make a structure like this. One is I can say, leave out some things. So I'm going to leave out carbon symbols. I'm going to leave out hydrogen symbols when they're on carbon. I'm going to leave out lone pairs, unless I want to emphasize them. Then I might show them. Okay, so what can I do then? Well, just like over here, every line segment is an electron pair. Okay, so these all represent bonding electron pairs. If I'm leaving out the carbon symbols, I want to understand that every place that there is the end of a line segment, there's a carbon. And because I understand valence, I know that carbon makes 4 bonds. If carbon makes 4 bonds, well then for this carbon only 2 are shown. So there must be 2 more bonds. And we assume that those then are to hydrogen on carbon. And so this carbon has 3 bonds shown, it has a hydrogen on it. This carbon has 2 bonds shown, it has 2 hydrogens on it. This oxygen has 2 lone pairs. I left them out, and I might have left out the line between the oxygen and the hydrogen. So by understanding valence, I can see that this picture means exactly the same thing as this picture. And by doing that, I can have structures like this where I can leave out some information. So I could go back and draw all of the carbons in. I could go back and draw all of the hydrogens in. I could go back and draw all of the lone pairs in. But nobody wants to do that.